Hi, I'm John McMillan, and I'm here today with Steve Hughes to talk about PCB-level thermal analysis. Welcome, Steve.
Thanks, John. Always a pleasure to see you. As engineers become design specialists, that is, they're becoming responsible for more and more of the design flow and less of a dedicated tool expert, it's important that they have access to easy-to-use analysis and verification tools that they can just pick up and start using right away. Hyperlink's thermal falls into this category and can also be used for virtual prototyping.
So PCBs can either be a key part of the design, especially in cell phones and the new breed of IoT devices, or, as is often the case, just a piece of the overall system. Either way, thermal analysis at the board level is still a critical piece of the overall design flow, right?
John, yes, it is. Before any system level or flow analysis is performed, the engineer wants to know that the constituent pieces are operating within his design margins. So they need to be able to run fast and accurate modeling analysis to determine the thermal impact of the PCB placement and routing.
So what characteristics are they specifically looking for?
Well, they need to identify component and PCB hotspots quickly and efficiently, using what-if analysis to take into account all the major heat transfer mechanisms. Mechanisms such as convection, conduction, and radiation, to determine the optimum placement, cooling techniques, and stack-up design.
Let's bring in a subject matter expert to see and hear what he has to say on this topic.
Thanks, John and Steve. I wanted to show how easy it is to run a thermal analysis with PADS Professional or PADS Standard Plus. The Analysis X board is a single menu pick for signal integrity, power integrity, and thermal analysis. So you can run multiple different kinds of analysis on your exported board. Running a thermal analysis is as simple as a single button click, which of course is using default power dissipations, but it gives you a pretty good idea of the thermal profile of your board. In addition to using defaults, it can also be set up to use any power dissipation information you have set up in the part library. The environment is broken down in some easy to modify parameters, so you can look at changes in airflow velocity and directions fairly easily and resimulate. This being a line card, it's going to have some cooling at the very edge where it's connected to the chassis, so you can model that effect as well. And we can resimulate and look at different design trade-offs for cooling down the board very quickly because Hyperlink's Thermal has a very fast and accurate simulator. You can also look at the effect of adding cooling components like heat sinks. And very quickly look at the changes that results from adding those kinds of components. And here you can see just with a few simple changes we've been able to reduce our peak board temperature by almost 20 degrees C, and we have a nice cool line card design. All of the models used are three-dimensional models, so you get an accurate modeling of the diversion of airflow, so that's accurate modeling of both forced and natural convection, in addition to radiation and conduction.
Great expert advice. So John, I really like how easy it is to get up and running with Hyperlink's Thermal. Even someone like me with limited thermal simulation knowledge could easily create a virtual prototype and use the what-if capabilities to identify and fix hotspots, using the full range of cooling techniques available.
Well, I agree, Steve. It is very easy to use. If you want to learn more about the features presented and discussed today, be sure to visit pads.com. There you can request a free evaluation, watch demonstration videos, and explore all of the PADS product suites. Thanks for watching.
And we'll see you next time.